Hello students, we shall look into green energy, that is module 5 in energy engineering. This is part 2. We already discussed about biofuels in part 1 and this is part 2 which deals with green energy, and in this discussion we will discuss the various fuel cells basically. I am Professor Suresh Mane, working at GSIT Carver. So what is a fuel cell? So as the name itself indicates, there is some fuel and there is some cell. So as you know, cells means cells or batteries. So what they do, they produce electricity. Okay, they store in electricity and also release electricity. Here also, fuel cell means it takes some fuel, mostly hydrogen, okay, and along with air or oxygen, and it produces electricity. Simple. So these fuel cells actually, a lot of research has been going on for many years now, but so far they are not very commercially viable. Like you see uh, petrol cars, diesel cars, and now electrical cars. But fuel cell cars are not commercial. I think this month only we saw that Mahindra company along with that CSIR as well as KPIT, they tested that Mahindra Verito fuel cell car. So in days to come, because the advantage is the only reaction takes place between hydrogen and air, and there is no pollution and only water comes out. So it is a very clean technology. But as of now, it is slightly expensive, so that is why not many cars are available. But globally, lot of R&D is going, and many leading car manufacturers also making this fuel cell technology cars. The fuel cell is a electrochemical cell that converts the chemical energy from a fuel into electricity through an electrochemical reaction of hydrogen fuel with oxygen or any other oxidizing agent. So fuel cell is a cell, electrochemical cell, which generates electricity by chemical reaction of hydrogen with oxygen. This is not combustion. Please understand, this is not combustion. Fuel cells are different from batteries in requiring a continuous source of fuel and oxygen, usually from the air, to sustain the chemical reaction. Whereas in a battery, the chemical energy comes from chemicals already present in the battery. So you know batteries, they have positive plates, negative plates and electrolyte. Similarly here also in fuel cells you will have positive plates, negative plates and catalyst. Fuel cells can produce electricity continuously as long as the fuel and oxygen are supplied. So like your car engine, if you supply petrol and air, it will produce energy. Similarly, fuel cells will keep on producing electricity as long as you supply the fuel and oxygen. Now let us look into the working principle. The fuel cell is a device which uses hydrogen or hydrogen rich fuel like ammonia and all and oxygen to create electricity by an electrochemical process. A single fuel cell like your photovoltaic cell, single cell, consists of an electrolyte sandwiched between two thin electrodes. That electrode means positive and negative, that is cathode and anode. Hydrogen or hydrogen rich fuel is fed to the anode, where the catalyst separates hydrogen's negatively charged electrons from positively charged ions, that is protons. So hydrogen is normally supplied at the anode, okay, and in this anode when the hydrogen is supplied, there is a catalyst inside which separates the hydrogen ions, positive ions and negative ions Okay, the positive ions are called as protons and negative ions are called as electrons. At the cathode, the oxygen combines with the electrons, and in some cases with species such as protons or water, resulting in water or hydroxy ions respectively. So at the hydrogen is supplied from the anode. At the cathode, oxygen is supplied, and this oxygen combines with the electrons, or it can combine with protons also, and produces water or OH, that is hydroxy ions. The electrons from the anode side of the cell cannot pass through the membrane to the positively charged cathode. They must travel around it by an electrical circuit to reach the other side of the cell. So the electrons which are produced at the anode side because of the hydrogen splitting, they can't go through the chemical route. They have to go through the electrical route to the cathode. So this movement of electrons is called as electricity or electrical current. The amount of power produced by a fuel cell depends on various factors such as fuel cell type, cell size, the temperature at which it operates, and the pressure at which the gases are supplied to the cell. Still, a single fuel cell produces enough electricity for only the smallest applications like the photovoltaic cell. Therefore, individual fuel cells are typically combined in series into a fuel cell stack. So the typical fuel cell stack may consist hundreds of fuel cells. Because our power requirement is high, so we cannot have small cell. We will have a stack, fuel cell stack. Many fuel cells will be there. So fuel cells are primarily classified based on the kind of electrolyte they apply. This determines the kind of chemical reactions that take place in the cell, the kind of catalyst required, the temperature range in which the cell operates, the fuel required, and other factors. So fuel cell will always have that anode, it will have a cathode, it will have an electrolyte. But only the electrolyte will make the difference. And that is how the fuel cells are classified. There are several types of fuel cells currently under development, each with its own advantages, limitations, and potential applications. As discussed earlier, a lot of research is going on from many years, starting from space technology because it was used in space earlier, and now people are going for automobile applications also. So every technology has its own positive points, advantages, disadvantages, and potential applications. So what are the classifications of fuel cell? Based on the type of electrolyte, like AFC, alkaline fuel cell. Number 2, phosphoric acid fuel cell, PAFC. Third is polymer electrolytic membrane fuel cell, that is also known as solid polymer fuel cell, and also known as proton exchange membrane fuel cell, PEM fuel cell. These are extensively used for automobile applications. Then you have got molten carbonate fuel cell, and lastly you have SOFC, that is solid oxide fuel cells. So we will see these fuel cells one by one.